Hey, Ethan.
Hey, how's it going?
I've got this design that I'm working on that is using multiple voltage domains, and I'm using a discrete level shifter for my project to interface with each of the components. But the problem I'm having is that it's taking up too much space, it's driving up my bill of materials, and it's complicating my overall design. Is there a better way to handle this?
Yeah, that's a great question. When designers start to design these applications, whether that be an IoT device, an industrial application, or an automotive application, most of the times these designs have components that operate at different voltage domains, and in order to interface them with one another, you would have to use a discrete level shifter. But like you said, the drawbacks to this is it can increase design complexity, increase your BOM, and it can eat up board space, which is important in space-constrained applications. We have a core-independent peripheral called multi-voltage input-output, or MVIO, that addresses the challenges that discrete level shifters have. Here, let me show you. What makes MVIO a great solution to the challenges posed by discrete level shifters is that it is essentially an integrated level shifting solution built directly into the microcontroller's hardware. This allows specific I/O pins to seamlessly interface with components operating at different voltage levels independent of the core supply voltage, whether it's higher or lower, across a wide range of voltages, all without requiring any external components. MVIO works with both GPIO and select peripherals, providing the flexibility needed for diverse design requirements while simplifying and streaming multi-voltage systems. And when you buy these microcontrollers that have MVIO on them, you're not just getting the microcontroller and MVIO, you're also getting a full set of other peripherals as well. This can range from analog peripherals to communication peripherals. And what this means for designers is that it essentially provides a whole product solution for a diverse range of applications. And by eliminating the need for discrete level shifters and using an integrated level shifting solution like MVIO, you're going to decrease your design complexity, decrease BOM, and use less board space, all while still improving system reliability.
MVIO sounds interesting. I've had problems with level shifters before where it's not providing the right voltage to the pins I need, which causes issues in my circuit. And at other times, the main power supply, if it's unstable, causes the shifter to be unreliable. And it's frustrating because there's no way of knowing where that problem is coming from because there's no built-in debugging features. Does MVIO help with this?
Yeah, for sure. So unlike discrete level shifters, which don't provide any intelligent feedback, our MVIO has a built-in mechanism that can protect it against power supply failures. So for example, if the microcontroller's core or the MVIO's power supply drops below a minimum threshold where they can no longer reliably operate, the MVIO will tri-state its pins up until the power supplies exceed the minimum startup level where it can then reliably operate again. And at this point, the pins will either be reset to the MCU's I/O configuration or power and reset defaults depending on whether if it was the microcontroller's core or the MVIO's power supply that dropped below that minimum threshold. And additionally, there's a status bit in the microcontroller that indicates whether or not the MVIO's power supply is above the operating point. And you can also internally measure the MVIO's power supply using an analog to digital converter for further monitoring capabilities. Overall, our MVIO solution is a great peripheral to add in multi-voltage system designs where it can add flexibility and versatility to your design.
Thank you so much. I think I'll start using MVIO on my design.
No problem. Have a good day.
You too.